Hello, hello, hello everybody, and thank you for joining me once again. We're looking now at question number 8 on the Manitoba Math Contest from 2017. Question 8 looks like this. A convex quadrilateral has side lengths A, B, C, D, with side lengths of A and C opposite. Okay, I can draw the picture now and label it appropriately. Prove that if a squared plus b, or a squared plus c squared is equal to b squared plus d squared, then the two diagonals of the quadrilateral are perpendicular. Okay, the diagonals. So let's I guess draw a picture here. So a squared plus c, so it's opposite squares. So they didn't tell us anything particular about this quadrilateral, so we'll just sort of draw one. So we were told A and C are opposite, and that tells me B and D are opposites. And we want the diagonals, so let's add the diagonals in. I can draw better diagonals than that, I really can. Close enough. Okay. So we're told opposite squares add to the same value. And we want the diagonals to be perpendicular. So we have these. If I show just one of them is perpendicular, then its opposite has to be perpendicular, and the ones beside them have to be perpendicular because they add up to lines. 180 degrees in a line, if one of the angles is 90, the other one must be 90. So I suppose it suffices just to show that, say, this angle here, which I guess ABCD will call it angle E, suffices to show that E must be. And so then this guy here is E, and this is 180 minus E. 180 minus E. Okay. So I'd make a note of that. It suffices to show E is a right angle. Okay, so as soon as I manage to do that, then everything else will fall into place. They'll be perpendicular. Okay, but the only fact I'm given here is opposite squares add up to the same thing. Okay. So an angle here like E, and sort of he only relates to this A. I mean, we sort of have this smaller triangle here. I guess the only thing I can think of with these squares here is cosine law. But cosine law requires me to have everything else named. So I don't know, call that x and that y, and the one diagonal will be p, so we'll call that px, q minus y. But I suppose we can now get some cosine laws in here. So I'll just write down what I've done. Let p, q equal the lengths of the diagonals. Let x and y be lengths from corners or vertices to the intersection of the diagonals, which, because it's convex, is inside the quadrilateral, and I guess maybe we should make a note of that. So let these be the lengths so that A, X, Y form a triangle. Okay, just as shown. I mean, you could probably just get away with labeling the X and Y on an appropriately drawn diagram. Okay, so by cosine law, we're going to have 4 cosine laws, so I'm hoping that there's something else we can do. But yeah, when we're talking about an angle and we have the diagram labeled, with the a squareds and the c squareds and the b squareds and the d squareds, that's really the only thing I can think of is cosine law. So a squared is x squared plus y squared minus 2xy cosine e. And c squared is everything else, so it's p minus x squared plus q minus y squared minus 2p minus x q minus y cosine e. So I can add these and group the cosine e's, and if I add these up, I'll get a squared plus c squared is going to be p squared minus 2px plus 2 copies of x squared plus q squared minus 2qy plus 2 copies of y squared. And then, okay, minus 2. We'll put the cos e with the 2. And then what have we got? We've got an xy, a pq, a minus qx, a minus py, and then plus another xy. Okay, it seems like I've introduced 5 variables when I only had 4, but should get a similar sort of expression for b squared and d squared and add them up, and I suspect a lot of things are going to cancel. That's what I'm hoping for, at least. So p is x squared plus q minus y squared minus 2x q minus y cos of 180 degrees minus e. But that can become plus cos e. And you'd probably need a separate line explaining that, or I'll just write it off to the side. Cos of 180 minus e is negative cos of e. But now I've got everything back in terms of the cos e's. And I think my goal here, if e is 90 degrees, we need to show cosine of e is 0. So now p minus x squared plus just y squared plus 2p minus xy cos e. Alright, so then b squared plus d squared is going to be p squared minus 2px plus 2x squared. Ooh, that's looking good. Plus q squared minus 2qy plus 2 copies of y squared. And then plus 2 cos e. And then what have we got? We got xq minus xy plus py minus xy. Okay. And a squared plus c squared, and if I subtract these, I get 0 on one side. But a squared plus c squared was p squared minus 2px plus 2x squared plus q squared minus 2qy plus 2y squared minus 2 cos e. And now I can't remember what it all was. 2 xy's, pq, qx, and py. Oh, sorry, minus qx. Right, yeah, minus qx minus py. Alright. But when I make this subtraction, these cancel, these cancel, these cancel, these cancel, these cancel, these cancel, and now we're left with 2 cos e, and then xq minus xy, actually minus 2 xy's. Right, and then plus py, and then plus, right, because it's negative of a negative. So it'll be plus 2xy plus pq minus qx minus py. Okay, and then switching colors again, those cancel, and those cancel, and we're just left with 2pq cos e. But p and q aren't equal to 0, and that tells me cos of e must be equal to 0, and that tells me e must be 90 degrees. All right, and that's all we needed to show, was that the diagonals were perpendicular. So that wasn't bad. I liked the setup because cosine law really was the only thing to go. I mean, you draw a picture with the diagonals, and you say, what do I need to show? I need to show an angle. An angle needs to be 90 degrees, and we're only given this stuff with squares. That makes you think cosine law. It's just a question of what do you name things and how do you set up so cosine law helps you. But not bad at all. I like that question. It's a good question. So that wraps up question 8. We've got 2 more to go in this the particular Manitoba contest. So join me in the next video for question number 9. And if you want to, feel free to like or subscribe. Or if you manage to do this question in a different way, feel free to comment that. But either way, I will see you guys for question 9 in the next video. And until then, have yourselves a wonderful day.